One of the really interesting additions to the C++ language is the reference operator. And it's easily misunderstood by new programmers to C++. So pay close attention. Hopefully we get it right the first time. Okay, so the reference operator is basically a new way of making a pointer, but it's a simpler pointer than what we had in C. Okay, so here's how it works. Let's say I have a normal variable x, and then I can declare a reference to x by putting an ampersand to the left of y. And so what this is saying is that y is now something called a reference, and y references x. And so any change I make to y is really a change to x. So when I say y equals 5, I'm actually changing x to 5. And then when I print x here, I'm not going to see 10, I'm going to see 5 because y and x are the same variable. I've made y point to x. Y and x are aliases. Y references x. Okay. So that's pretty cool. And one of the nice things about this is that you don't have all the annoying pointer syntax, right? I didn't need to take the address of x, and then I didn't need to dereference y to change x's value, right? I just use y like a normal variable, but really I'm changing x the whole time. That's pretty nice. It's easy to be confused at first about where you put this reference operator, but it's actually a really simple rule. Okay, the reference operator can only appear in a declaration. It can't appear anywhere else. And when it appears in the declaration, it's going to appear to the left side of a variable's name. So here I'm declaring y. The declaration between the type and the variable name, I put this ampersand. And that means it's a reference. Y is a reference. And it's referencing x. Okay, it must be to the left of the variable name, but there can be spaces in here. That's fine. It's not like literally on the name. We ignore white space in C and C++. It just needs to be somewhere to the left of the variable, and that should be fine. Okay, now this is, here's another example. Now, because we set the reference operator at declaration, you can never change what a reference refers to. Now, this is the part that C programmers often get confused about. They think of it like a pointer, and so they think they can change what y is referring to, but you can't ever, right? Once y has been linked to x, and once y refers to x, it can never be made to refer to else. Right, so in this code, I'm setting x to 10, y is referring to x, and then I set w equal to 50. Okay, here I say y equals w. What does it mean if I set y equal to, you might think, well, y is a reference, so that means I'm changing y to refer to w, but no, that is, y can never change what it refers to, it's x. So what this means is I'm copying the value in w into x, okay? So x is gonna become 50. And now when I set equals 60, w changes. So when I print out y here, I'm going to print out the value of x, okay? And the value of x here has to be 50, right? Because y is the same as x, x got modified to have the same value as w, right? So we print 50. Now that's a little bit of a convoluted example. I just, to really emphasize this idea that once you set a reference to link to a given variable, it's always linking to that single variable, and you can never change it. Okay, and just to kind of emphasize the difference in notation between references and pointers, right? If I wanted a pointer in the C language or in C++, I would do it kind of like this. I would put a star next to the variable name, and then I would set it equal to a variable I take the address of. Notice here, the ampersand is on the right side of the equals, not the left. It's on the right side. And this means this pointer gets this address. Pointer gets the address of x. Okay, but when I have a reference, the ampersand is between the type and the variable name. It's on the left side of the equal sign. And I'm saying y is a reference and it's always referencing x. And you'll note that here I don't need to take the address of x. the compiler knows that I want to link y to x. Okay, now one of the primary use cases for references is with function calls. Because now what this means is I can use a reference in the argument of a function in order to pass a variable in by reference and modify it. So for example, here's my function f using a reference as an argument. And f is going to take a reference to some variable as its argument, and it's going to change that variable to have the value 51. And down here in main, I'm going to pass y into f. And what that means is that when I pass y into this function f, x is going to get bound to y. X is going to reference y. And so when I write x equals 51, actually I'm writing y equal to 51. And so when I print it here, I'm going to see the result of this modification. To do this same thing with pointers, then I would have to make x be a pointer. I have to make the argument to this function x be a pointer. And then when I pass y into it, I would need to take the address of y. And likewise, in the body of this function, I need to dereference x to change the location it's pointing to. Okay, we can also return references, but you need to be careful. We should only return references that are passed into the function as an argument. For example, let's say I pass in two integers and I want to know which one is bigger. I want to know the maximum. Then I could actually return the reference to the maximum as the return value. And what I'd basically be doing is like returning a reference to x, reference to y based on which one is bigger. And that makes perfect sense. And then down here in main, when I get the return value from calling max, then v is either going to reference w or z. And in this case, it'll reference z. And that's perfectly reasonable. But like, look over here on the right where I have this function called bad idea. I'm going to return a reference here, but I return x, which is a local variable. And what's going to happen is that x is going to be on the stack. And when this function ends, that memory location for x is popped and it's basically no longer valid. But I'm returning a reference to an invalid memory location. Clearly, that's not a good idea. And when I try to return this reference in main and use it, then I'm just pointing at garbage memory. It's not going to work. So as a rule of thumb, when you return a reference from a function, make sure that what it's referring to is legitimate. And one simple way of being sure of that is just return a reference to something that was already passed into your function. Or return a reference to something that's global, or to something on the heap that you're sure is still legal to reference after the function ends. But definitely do not return references to local variables. That's a bad idea. Okay, so in summary, references give us the power of pointers with a simpler syntax and usage model. It's especially useful for passing variables by reference to functions. It's also important to keep in mind a reference cannot change what it refers to. Also, fundamentally, there's still pointers under the hood. You know, if you were to look down at the assembly code at how they're working, they're pointers. It's just they're a very restricted kind of pointer that you can never change what it's pointing to. But because they're pointer, they can become invalid if they refer to memory that's no longer accessible, like a pop stack variable. So just be careful of that when you use them. But enjoy the simplicity of having references. You can get the same functionality as pointers without all the extra annoying syntax.